So, potential, kinetic, and mechanical energy are three simple kinds of energy that are best explained in the form of a roller coaster. And that's really fun to look at because as the coaster is pulled up the lift hill, it's just gaining potential energy because potential energy is determined by the height of an object. And then when it gets to the part where it finally has to drop down, take a big drop, then all the potential energy is converted into kinetic energy as it runs down the track by itself. And if you look at the whole roller coaster, the whole thing, it's got mechanical energy, which is the combination of kinetic and potential energy together. The law of conservation of energy. That means that in a closed system, energy can't be created or destroyed. It can only change forms. So say you have a light bulb. So say you have a slightly better light bulb. So how did the light bulb get its light? Well, it originally came from a few different places. Maybe the wind, maybe the sun. So say the sun goes to a solar power plant. The solar power plant captures the sun waves and turns them into electrical energy. That electrical energy is transferred to your house, where it goes to the light bulb. Then the light bulb changes that electrical energy into light energy. Then, in the process of making the light energy, light bulbs also get really hot. They also produce a lot of heat energy. So, energy can change forms, but it can never be destroyed or created. So gravitational potential energy is a measure of something's energy by its mass, its distance to the ground, and the gravitational acceleration. So say we have a boulder on a cliff. The boulder weighs 1,000 kilograms. That's 1,000 for the mass. And say that the cliff is 30 meters high. So that's multiplied by 30. And then gravitational acceleration of Earth is 32 feet per second, or 9.8 meters per second. We'll just use an estimate of 10 meters per second, so multiplied by 10. And then 1,000 times 30 times 10. Be back in a second. Okay, so it turns out the gravitational potential energy of that boulder would be 300,000 joules. 300,000 joules. To solve a potential energy equation, you need to know the formula for potential energy first. The formula for potential energy is that potential energy equals mass multiplied by the gravitational pull of Earth multiplied by the height of the object. Here's the potential energy equation that we need to solve. So we say we have a flower pot that weighs 3 kilograms. So that's the mass, 3. And for simplicity's sake, we'll use 10 meters per second as the gravitational pull of Earth. So multiplied by 10. And then multiplied by how high it is. Say it's 10 meters off the ground. So 3 times 10 times 10 is equal to 300. And that is 300 joules is the amount of potential energy that the flower pot has. 300 joules. Okay, to solve a kinetic energy equation, you need to know the formula for kinetic energy, and that is 1/2 mass times velocity squared. Say you have an object that it weighs 2 kilograms. So it's 1/2 times 2. That's 1/2 times the mass. And then you need to know the velocity. So say it's moving at 10 meters per second. So then you multiply that by 10, which is the velocity, squared. And then 1/2 times 2, that's 1, multiplied by 10 squared. 10 squared is 100. So 1 times 100 is equal to 100. And so that object has 100 joules of kinetic energy. Learning science style. Science style. Radiation, it's from the sun and it's in light bulbs, used in atomic bombs and in x-rays at the doctors. Bakes a tasty buttery snack that you and I call popcorn in the microwave. Next we got conduction. It's where the particles get together and start touching to transfer energy between each other, just like that. Just remember, cause when it's heat it flows from hot to cool. Remember that. Convection in the lava lamps, it makes them rise. What a surprise. In the oven it bakes food even right in my home. The currents flow. Yet another way you're popping that popcorn. Learning science style. Science style. Learn. Learning science style.
Insulators are the things that keep off and so cool. They do not allow the heat to keep moving on and onward. Wear a coat and you will feel it getting a lot hotter. It intubates your body.
The conductors, they transfer energy as heat and electricity. Most of them are metals and pass the current easily, which is why they're used for cooking things and your wiring, all their wiring.
I hope that you learned something you didn't know.
Hey,
You didn't know. Hey, I'm sorry. We gotta end it. We gotta go. Hey, we gotta go. Hey, heat and energy are fun to learn about.
Learning science style.